On June 28th, NASA's Low-Density Supersonic Accelerator project conducted the first shakeout flight of a new way of testing technologies that will one day be used to land heavier, more massive payloads on the surface of Mars. We used a large 34 million cubic foot scientific balloon to hoist a 7,000-pound test vehicle to an altitude of 120,000 feet. The test vehicle was then released from the balloon, spun up for stability, and a large solid rocket motor accelerated to over 4 times the speed of sound and an altitude of 180,000 feet, a condition very similar to the conditions it would see at Mars. Once we reached the correct speed and altitude, we despun the vehicle. And then we got a chance to test our new supersonic inflatable decelerator. The camera lens covers deploy. We see that inflated very uniformly without disturbing the vehicle too much. And now we're seeing previously unreleased, high-definition, high-resolution, and high-speed video taken during the test. We used the supersonic inflatable decelerator to slow us to something closer to 2.5 times the speed of sound. We use a balloon to help deploy the new supersonic parachute. The balloon is shot out the back of the vehicle at over 200 feet per second, and then we cut the balloon free and it begins to pull the parachute off the back of the vehicle. As the parachute begins to inflate, we see one of the surprising aspects of this test, which is the early onset of tears in the parachute. We see where those tears began, how they propagated, and otherwise how the parachute behaved as it began trying to inflate behind this very blunt object moving 2.5 times the speed of sound, punching a hole in the atmosphere and creating an extremely turbulent, chaotic environment for the parachute to exist in. We now have a data set that we will use to prepare for 2 more tests beginning in June of 2015.